A 12-foot ladder is leaning against a house on flat ground. The house is to the left of the ladder. The base of the ladder starts to slide away from the house. When the base has slid to 10 feet from the house, it is moving horizontally at a rate of 3 feet per second. How fast is the ladder's top sliding down the wall when the base is 10 feet from the house? So let's start by drawing a diagram. So this is the house, and this is the ladder leaning in the house. And the question gives us that the ladder is 12 feet long, so we could label that. And this is the ground, and let's label this Y and X. So the question gives us that the ladder is moving horizontally at a rate of 3 feet per second. So we have to look at the horizontal variable, which is x. So dx over dt equals 3 feet per second. And this is when the base has slid 10 feet from the house. So x equals 10. Now the question's asking how fast the ladder's top is sliding down the wall when this occurs. So in other words, it's asking for dy over dt. So let's define up and right as positive. So this will stay as positive. And we can imagine if this is moving to the right, the top of the ladder will have to move down. So we should expect dy over dt to be negative. So since we could see it makes a triangle, we could use Pythagoras to solve this. And we're just going to call the hypotenuse z. So z squared equals x squared plus y squared. And let's differentiate with respect to time on both sides. So we're going to get 2z dz over dt equals 2x dx over dt plus 2y dy over dt. So we have z, we have x, we have dx over dt. We could find y using Pythagoras again. So a lot of students get confused with what dz over dt means. dz over dt is how fast the ladder is changing length. So as it slides down the wall, we're going to assume that the ladder is not extending or collapsing. So dz over dt would be 0 because the ladder's length is constant. So let's write that. dz over dt equals 0. Now we have 10 and we have 12, but we need to find y. So let's use Pythagoras to find that. So you'll get 6.63. So let's just write that over here, and we could erase this. So now plugging everything in, we get 2 times 12 times 0. So the left side will be 0 equals 2 times 10 times 3 plus 2, 6.63 times dy over dt. So if we rearrange for dy over dt, we're going to get dy over dt equals negative 2 times 10 times 3 over 2 times 6.63. And this negative came from me bringing this to the other side because this all goes to 0. So plugging that in, you'll get negative 4.52. And looking at the units, that should be in feet per second. And again, the negative makes sense because the ladder would be expected to fall down the wall as this moves to the right. So that's our final answer. A 9-foot long ladder is leaning against the wall. The top of the ladder is sliding down the wall at the rate of 2.5 feet per second. How fast is the bottom of the ladder moving along the ground at the point in time when the bottom of the ladder is 5 feet from the wall? So let's draw a diagram. So that's the house and this is the ladder. The ladder is 9 feet tall. And let's complete the triangle. And let's also label the triangle. So this is Z, X, and Y. So the question says the top of the ladder is sliding down the wall at 2.5 feet per second. So that would be dy over dt equals negative 2.5. Again, because it says it's sliding down and we define up and right as positive. So we're looking for how fast the bottom of the ladder is moving along the ground. So that would be dx over dt when the bottom of the ladder is 5 feet from the wall. So it gives us x equals 5. So let's find side length y because we know we're going to need it. So we have 9 and 5. So we could just solve for y. So you're going to get approximately 10.3. So we could just erase this. And again, we're going to assume that the ladder's length is not changing because the question didn't make note of that. So dz over dt is 0. Now we could set up Pythagoras and differentiate with respect to time. And we have everything here to solve, so we could just plug in some values. So 2 times 9 is z times 0, so this will all be 0 again, equals 2 times 5 times dx over dt, that's what we're looking for, plus 2 times 10.3 times negative 2.5. So isolating for dx over dt, we're going to get 2 times 10.3 times 2.5 over 2 times 5. So the top is positive because when you bring this over to the other side, instead of positive, it's going to be negative, and then negative times negative is positive. So you should be able to work that out. So dx over dt equals 5.15. And again, looking at the units, it should be in feet per second. So it makes sense how it's positive because if the ladder were to slide down the wall, we would expect the bottom of the ladder to move to the right. So that's our final answer.